Hey Year 7s, this lesson will be looking at the skill add and subtract fractions with related denominators. The learning goal for this video is to see the maths behind working with two fractions that have the same or what's considered as related denominators, and the success criteria is to be able to add, subtract, and simplify related denominator fractions. I've taken a few examples from the Essential Assessment program. Now, when it comes to fractions, whether adding or subtracting or multiplying fractions, it's easy to just grab our calculator and use the fraction button, which is right here. But the thing about this is that while we can do this to get our answer, that is training you to be robots and not really true mathematicians, because we want to know why 3/9 plus 4/9 gives us the answer that it does, and not just simply rely on the calculator. The calculator is used as a tool to either confirm certain answers or help us with a certain skill. In this case here, we have 3/9 plus 4/9, which is the first question given in your worksheet. Now, a lot of people will assume, especially if they're not familiar with fractions, they'll look at this fraction here and they'll assume, okay, I'm going to grab the top number of each fraction and add them. So 3 plus 4 is 7 in this case, and get the bottom number of the both fractions and add them. 9 plus 9 being 18, and 7/18 should be my answer. But this is actually incorrect. This is not the correct way of adding fractions, because when we add fractions, we have to consider a different set of rules, because we're now dealing with a different set of notation, namely fractions. And when you add and subtract fractions, you go into a different world, okay? The first part is making sure that when we look at our fractions, that the bottom number, or the denominator, is the same for each fraction. In this case, this 9 and this 9 are the same. If they are the same, you can just go ahead and apply the operation of the top numbers. So 3 plus 4. So in this case, 3 plus 4 is 7. And if the number is the same for both of the fractions, then they stay the same for your answer. Now, many students will be wondering why this is the case. Well, imagine if I'm gonna draw this up, and this is gonna be considered as one whole, and this is gonna be considered as another whole. And I'm gonna split this up into thirds, just like this. And hopefully, 1, 2, 3, 4, 5, 6, 7, 8, 9. This one chunk here on the top is one whole, and it's split up into 9 parts. And the second chunk is also another whole, split up into 9 chunks as well. And now let's look at the first fraction. We have 3/9, or 3 chunks out of the 9. Like so. And then we're going to add an additional 4/9, which is here. And so the question's pretty much asking, okay, if I have 3/9 and I add another 4/9, how many 9s do I have all up? Well, we just count out how many 9s we have, and alternatively, we can just get these 4/9 and add it to the top part here. So let's get a different color, just to indicate that I'm going to put them into here. So there's 1, there's 2, there's 3, and there's 4. So right now I've got 1, 2, 3, 4, 5, 6, 7 9ths out of a whole chunk. And that's how we got our answer here, 7 9ths. So in this case, here is our answer, 7 9ths. So don't just go for the calculator, reach it out and just put 3/9 plus 4/9. Challenge yourself and see if you're able to answer this question without the calculator. Now, this only can work if the denominators are the same. In this example here, which is question 6 from the worksheet, which answer shows the fractions simplified correctly? And here we have 3/5 plus 3/10. Now we run into a situation where the denominators are not the same and they are actually considered different. Now again, it's easy to just grab a calculator, put the answer in and obtain what the calculator tells us, but we're not robots, we're mathematicians, so we're going to try to figure out what we need to do. We have to make either one or both of these fractions, we don't know yet, equivalent or the same, so that way we can add the fractions together. Or in other words, we want to make sure the denominators or the bottom numbers are the same. So I'm looking at the 3/10 and 3/5. If you want to treat this as a set of rules of some sort, let's just picture, let's look at the biggest denominator out of both of them. So in this case, it's the 10. All right, now I'm just going to look at the number 10. All right, I'm going to write the 10. I'm going to put a little dot here. Now, this here indicates the number 0. And let's say I am the number 10. And I take a walk, and I walk here. So what is 0 plus 10? Well, in this case, it's 10. Okay, now you're probably wondering, what is Mr. Herman doing? What are we doing? We're actually trying to figure out if there is a way to get both of these as the same denominator. So once I do this once, I backtrack and I check my second denominator, which is a 5. So I'll get a different color. I'm gonna start at 0 and I'm gonna step until I reach this number here. If I don't reach it, then this number 10 has to go again. And in this case, we go 5. So there is 5. We just added 5. And then we go again, 10. And another 5, so we're at 10. So in this case, this number 5 has taken 2 steps to get to number 10, where the number 10 has only taken 1 step. If this top number takes 1 step, we don't have to change this 3/10. We just leave it as it is. But in the other case, this number goes up twice. And because of this, we have to times both the numerator and the denominator by 2. Because it's taken 2 steps. If this was 3 steps for whatever reason, we have to multiply by 3. In this case, it's only 2 steps, so we have to times the top number and the bottom number by 2. So instead of 3/5 plus 3/10, this is actually 6/10 plus 3/10. And what this 6/10, we haven't necessarily just magically changed the fraction. 3/5 and 6/10 are actually the same fraction. They are the same fraction, and we can prove this. 6/10, if I were to put 6/10 into our calculator, like so, press equals and it simplifies, we'll get 3/5 because they're the same. It's just a simplified version for it. But we're kind of doing the opposite. We're unsimplifying it in a sense, as one student said. We are making it equivalent, and we're purposely putting it as a 10, so that way we're forcing it to be able to add. So in this case, 6/10 plus 3/10 is equal to 9/10, which is this answer here. But then if we look at 3/5 plus 3/10, technically it's the same answer, 9/10. We've just kind of changed this number around, or forced it so the denominator is the same as the other one. If this, say, denominator was a 90, then we have to figure out how many steps does it take for 5 to get, not to get to 10, but to get to 90. And whatever that number is, we multiply both the numerator and the denominator by that number. This also goes for this example here, where we need to try to figure out a subtraction fraction. So now this 10/12 minus 2/4, I can see here that both of these numbers can actually, or both of these fractions rather, can be simplified. Let's go ahead and simplify this first. 10/12, if we were to get a calculator and write 10/12, now there is a way to do this by hand. But for now, I'm just going to use the calculator as a tool to help us get 10 12 simplified, which is 5/6. So 10 12ths is the same as writing 5/6. And we're going to minus 2/4. Now let's simplify 2/4 and see what we get. Alright, so right now we've got 5/6 and we're subtracting 1/2. Now, unfortunately, the denominators are still not the same. Alright, it's good to check to see if this is the case, but unfortunately they are not. But we can still use this. We can still use this set of fraction. It's exactly the same as this, just written in a simplified way. So I'm the number 6. I always take the biggest denominator out of both of them, and I take a step and then get to 6. Starting from 0. And then I'm the number 2, and this goes up 1, 2, 3, 2, 4, 6. So in this case, how many steps have I taken? 1, 2, 3 steps to get to 6. I have to times this by 3 and times this by 3 to make the fractions equivalent. So in this case, this is 5/6. Take away 1 times 3, which is 3, and 2 times 3, obviously, being 6. So 5/6 minus 3/6. Now that the denominators are the same, your answer for the denominator will still be the 6, and we're just figuring out what 5 minus 3 is, which is 2/6. Now, just in case, let's put this into a calculator, and let's see if 2/6 can be simplified. Yes, it can. It can be simplified to 1/3. Meaning that will be the answer. A few more examples. Here we have a cake, and if Kate has 3/4 of a cake left over from a party and then gives 1/8 of the full cake to her mum, how much will remain? So right now we're looking at 3/4 of a cake left over from a party, so there's the 3/4 here, and then gives 1/8 of the full cake to her mum. So we're taking away 1/8 of that cake. Now, the denominators, they are not the same. We're going to try to force this 4 to look like an 8. Now, hopefully by now, you try to figure out how many times does 4 need to step to get to 8. That's just twice. So we're going to times the top and the bottom by 2, so we can force this fraction here to have the same denominator as the second fraction, or in other words, 6/8, because 3 times 2 is 6 and 4 times 2 is 8. Subtract 1/8, we end up getting 5/8. And that's how much will remain after Kate gives 1/8 of the cake to her mum. We've got 2 more examples. You'll get a question that will look like this: which answer shows the fraction simplified correctly? And here we have 2/7 times 3. 2/7 times 3. Now, I'm going to show you what you need to do in order to answer this. The first thing we're going to do is we're going to figure out what does this actually mean. Remember, when something is being multiplied by a number, we're just doing repeated addition. Or in other words, we are doing 2/7 plus 2/7 plus 2/7. And I will keep going if I need to, but in this case, we only need to do it 3 times. So we're multiplying 2/7 by 3, or we're adding 2/7 to itself 3 times. In each fraction, the denominators are the same. And all we have to do is add 2 plus 2 plus 2, which is 6/7. Because you can imagine, my friend has 2/7 of a piece of chocolate, I have 2/7, and another friend has 2/7. How many 7ths of a chocolate do we have? Well, we've got 6/7. In that case, this is our answer. So this is one way of attempting it. The other way is whenever you have a number that is just by itself, regardless of whether it's in this position here or this position here, you just put that number over 1, okay? Because 3/1, that's the fraction form. It's simplified, just turns into 3, and you can have a look here just to double check, 3 over 1. This is just saying how many 1s go into 3. Well, that's 3 times. So we're just forcing this 3 to look like 3 over 1. So that way, whenever you have a multiplication sign, this is where the rules are a little bit different and they're actually, in my opinion, easier. You just have to multiply the top number with each other, which is 6. So 2 times 3 is 6. And you also do the same with the bottom, 7 times 1, which is 7. So before, when we were doing addition or subtraction, you had to make sure the denominators were the same. If it comes to multiplication, and just multiplication, not division, just multiplication, you can just multiply the top and multiply the bottom. And that will work fine as well. Alternatively, if you find this one easier, you can just do that. And the last question, we're looking at 2/5 multiplied by 4. So again, I can show you the long way. We're getting 2/5 and we're adding it to itself this time 4 times because it's being multiplied by 4. Obviously all the denominators are the same, so we keep it as 5 and we just add 2, 2, 2, 2, which is 8. Now you'll notice that 8/5 is not an answer here. 8/5 is not an answer here, and the reason why is because this fraction here is considered as an improper fraction. Improper fraction. And it doesn't necessarily mean it's wrong, because we're used to using the word improper for something that is incorrect. Improper just means it's been displayed in a non-conventional way, because we're used to the top number of a fraction being smaller than the bottom number. When we have this case, this is just saying, okay, we've kind of gone past what the denominator number is, and we've kept going a little bit. And we have to try to figure out how many times have we kept going. Or in other words, how many 5s go into 8? Well, we know that 5 goes into 8 once, so there's our whole. And then how many are left over? So from 5, we got 5, and then we go 6, 7, 8. So we have 3 left over. So 8 over 5 and 1 3/5 are technically the same answer. They are exactly the same. One is just written in improper version, and one is written as what's called mixed numeral version. This is a mixed numeral. So 1 3/5, this will be our answer here. Now again, we can do this question the other way, where we can have 2/5 multiply by 4 over 1, multiply the top 2 numbers, we get 2 times 4, which is 8, multiply the bottom 2 numbers, 5 times 1, which is 5, and again, same answer as here, and we would just apply the rules, see how many times 5 goes into 8, or see how many times the denominator goes into the numerator, get a whole number amount, and then see what our remainder is, and put that into a fraction. And this concludes this video. Go ahead and attempt this skill. Got a bit excited there. I just hit the record button to stop recording. And I'll see you guys in the next video. Bye-bye.